Hello, my fabulous chemistry students. Notes number 6, LeChateleir's principle is how we say that. He is very French, oh oui oui. Today we are going to identify equilibrium reactions and how they respond to stresses. After last notes, we learned a little bit about equilibrium. Today we're going to put it to its test. Lead in, how do we manipulate an equilibrium reaction to produce our desired outcome? LeChateleir's principle states that basically that dynamic piece we had from last homework, if an equilibrium is dynamic and always changing, if I stress it in any way with add product or add reactant, it will respond dynamically to relieve that stress. Okay? So, LeChatelier says how a system in equilibrium will respond to a specific stress. Now let's define stress, because this isn't, oh my gosh, I have a test tomorrow stress. This is me changing the temperature or the concentration or putting pressure on a system. Okay, and of course pressures are going to, of course, only go for gases. When a stress is added to the system, there will be a shift in that equilibrium to relieve the stress and form a new equilibrium. So here we go. I'm going to give you a little saying. It's called this: A, T, T. I will shift away from what I add towards what I take. A, T, T. One more time. Away from what I add towards what I take. A, T, T. Moving on. Shift will increase the rate of either the forward or the reverse reaction. If I get a shift to the right, the rate of the forward reaction will increase. Okay, you see how the big arrow is favoring now the products, and I favor making more products. Okay, if I shift to the right, okay, if I shift to the left, the reverse reaction will increase, showing a favor to the right or to the left of the reactants. I will make more reactants. Remember, these are equilibrium reactions, so they go both forwards and backwards. So here is a kind of stress. Concentration is a stress. So as the initial stresses or the equilibrium changes or shifts when a reactant or product is added or introduced or decreased, taken away, okay? When the concentration of a reactant or product is increased, the shift will go away from what I add. So I will help you out with 2 of these, and you will need to do 2 of them. How about I do 2 and 4, and I'll show you how I do this. Number 2, if we add oxygen to the system, would shift to the blank, and the concentration of NO would. So this, first of all, this bracket means concentration. So we need to have that in our backpack of knowledge right away. So let me find oxygen in this thing. It's here. So I'm going to increase oxygen. I'm going to go away from oxygen. So that means everything on this side, all of it, will increase. I go away from what I add. So the concentration of my NO will increase because I shift to the right. Okay, that's how it works. Okay, I'm going to do one more, and then I'm going to set you upon doing the other 2 the same way I did it. Now, let us do number 4. If we added NO gas, which concentrations would decrease? So I find NO gas, that's here. I'm going to go away from what I add, so everything here is going to increase. Therefore, everything here is going to decrease, even the NO itself. Okay? Now, the idea is I add it in a one-time shot, and then what happens? Well, the shift goes here, so I start using up this, this, and this, and this. I start using these all up to shift it left. Okay? So what concentrations would decrease? NO, H2O, and I'm going to throw heat in there because we're going to treat it like a reactant or a product, even though it isn't technically a concentration. Okay, I'm going to throw it in there for good measure. You need to do 1 and 3 practice to show me that you're engaged in the work. When the concentration of a reactant or product is decreased, I will shift towards what I take. So again, I will do 2 and 4. You will do 1 and 3 on your own, following my lead. So let me start with 2. If I remove O2, the system will shift to the which direction? So where's my O2? Here's my O2. If I'm going to decrease my O2, I'm going to shift towards what I take. See how we did that? If I shift towards what I take, these go down. These all go up. Sorry, I forgot the kilojoules. That's heat. So now let's reread the question. All right, so if I remove O2, the system will shift to the right. That's the big arrow I drew. And the concentration of glucose will, where is glucose? Glucose is here, and I drew an up arrow. So glucose will increase. 4. Let me erase what I have because I kind of marked this stuff all up. Okay. If I remove carbon dioxide, which concentrations will increase? So remove carbon dioxide. I go towards what I take, so the shift will go to the left. If I shift to the left, everything on the left goes up. Everything on the right goes down. If I remove CO2, which concentrations will increase? Well, that's everything on the left-hand side of the arrows. So that is CO2, H2O, and I'm going to put in the heat. Even though it's not really a concentration, just because I want you to be practiced in treating the heat as a reactant. Again, AATT, towards what I add, or away from what I add, towards what I take. Okay, that's the way I like to say it. Temperature. As the initial stress involves increasing or decreasing heat. Okay, so I see 2 reactions here. One, heat is a product. The other one, heat is a reactant. That's going to change how things work, okay? When the temperature or heat is increased, the reaction will shift away from the reaction site containing the heat in the endothermic direction. Okay, so we need to get that endo-exo straight. If I decrease the heat, you'll go towards the endothermic reaction. Now, I will go back to these first 2 equations. In the first equation, heat is a product. So if heat is being released, that's exo. In equation number 2, heat is being added to the equation, therefore it is endo, and that'll help us keep these things straight. Okay, but what I'm going to do is treat heat just like if it were a regular reactant or product, okay, depending on where it falls in my balanced chemical equation. So, number 1, if we add heat, to which concentrations will decrease? So if I add heat, I go away from what I add. Everything on the left will go up. Everything on the right will go down, even the heat. So I added heat. I did my LeChateleir. What will decrease? My NO, my H2O, and my heat. Okay, number 2, if we add heat, which concentrations will increase? Well, which one have the up arrows? NH3 and O2. Okay. Example 2, I'm going to leave you with 3 and 4 to do. Do it just the same way. Adding heat and removing heat. Remember, I go towards what I take and away from what I add. Now, pressure. Pressure is a stress that, of course, is going to affect gases only. We're starting to get a hang of that, gases only. And here's the tricky piece. The AATT doesn't necessarily work. But if I were to squish it, increase pressure, I'm going to go to the least number of gas molecules or least moles. Okay? If I decrease the pressure, give it a lot more space, I'm going to favor the one that has the greatest number of molecules. So the AATT doesn't necessarily work here. This is a good one where I could have done another visual for you and had been just videotaping me and my ugly mug on the screen. Where is my mouse? Let us scroll down. So, if the reaction contains no gas molecules, then it is going to have, of course, no effect on the reaction. So, example 1, if I increase the pressure, the concentrations of which species will increase. So, I have CO2 gas and CO2 aqueous. Okay, if I squish it together, I'm getting closer together, which is more aqueous, so that's going to be the CO2 in the liquid form. If we increase the pressure, the concentrations of which species will decrease. The CO2 gas will decrease because it's going to be closer together and form aqueous solution. If I decrease the pressure, the concentration of which species will increase. Well, if I give it more space, it's going to go into more gas. And then this one's going to be solid. Solid will decrease if I give it more space. Okay? Solids, liquids, gases. So example 2. If we increase the pressure, in which direction will the equilibrium shift? Count the moles. So it's all gas, so we're good there. I have 1 and 3, which is 4 total moles. And here I have 2. So 2 is less than 4. So if I increase the pressure, I will favor less moles, which is the 2NH3 gas side, or this side. Increase in pressure, the concentration of which will increase initially. Did I do something wrong? Oh, it just says which way will it shift. Boom. Okay. Initially, I will increase, in the 2NH3. I answered that problem first. Now, which will decrease the N2 and the H2. If we decrease the pressure, I did see Mr. Mooks getting a little goofy. Sorry, I'm not reading. If I decrease the pressure, give it more space, which will decrease initially. So I will go, if I decrease the pressure, I'm going to end up going from right to left. So my NH3 is going to decrease initially, and then my N2 and my H2 will increase. Okay, sorry, I just didn't read that thoroughly enough. I'm getting a little ahead of myself. This video is getting a little long. I know you wish it was over. So I might as well finish up. LeChateleir's. We now have practice packet 9 through 12 we can do. There is a POGL designed for just LeChateleir's. I would do most of those before I get on to the prep or the quizzes for CASA learning for kinetics equilibrium on LeChateleir's principle, how I respond to stresses. Sorry it was so long, guys, but it is over. Good luck and see you tomorrow in school.